Section 1 practice, we're going to be going over composition of functions, one-to-one functions, and then verifying if two functions are inverses and finding an inverse. So remember, a composition is evaluating a function with another function. And then a function is one-to-one if it passes the horizontal line test. In order to check if two functions are inverses, both compositions must equal x. And then when you're finding the inverse of a function, you set it equal to y, switch x and y, and then resolve for y. So let's start with reviewing composition. So given f of x is 2x minus 1, g of x is x squared plus 4, we want to find f of g of x and g of f of x. So we start with f of g of x. So that means we're replacing every x and f with our equation g. So we start with 2. The x gets replaced with x squared plus 4, and then minus 1. Distributing the 2, you get 2x squared plus 8 minus 1. And then combining like terms gives us 2x squared plus 7. For g of f of x, we are replacing the x and g with our equation f. So it starts with x squared. So we're going to have in parentheses 2x minus 1 squared, then the plus 4. Remember, if I have 2x minus 1 squared, I have to expand it. I have to do 2x minus 1 times 2x minus 1. So I have to distribute. So we're left with 4x squared minus 2x minus 2x plus 1, and then we still have our plus 4. And combining like terms, we're going to get 4x squared minus 4x plus 5. Second example is verifying or checking to see if the functions f of x equals 2x minus 1 and g of x equals 1/2 x plus 1/2 are inverses of each other. So we're finding f of g of x first. So we'll do 2 times 1/2 x plus 1/2, then our minus 1. Distributing, 2 times 1/2 is 1, so we get x plus 1 minus 1, which gives us x. So far, so good. Now we want to check g of f of x. So that'll be 1/2, and then in parentheses, 2x minus 1, and then plus 1/2. 1/2 times 2 is 1, so we have x minus 1/2 plus 1/2, which becomes x. So yes, they are inverses of each other. Last two examples are going to be finding the inverse. So we have f of x equals 3x minus 5. So my first step is to write it as y equals 3x minus 5. Next, we're going to switch x and y. So we get x equals 3y minus 5. Now we're going to resolve for y. So my first step is going to be to add 5 to both sides. So we get x plus 5 equals 3y. Then we're going to divide by 3. So you have two choices here. So when I write it in inverse notation, I can write it as f inverse of x equals x plus 5 all over 3. So that's one option, to leave it as a fraction. Your second option is to write it as f inverse of x equals 1/3 x plus 5/3. Both of these are correct and acceptable. For our second example, we have g of x equals 1/2 x plus 9. So again, we're going to start by writing y equals, and then 1/2 x plus 9. Switch x and y, so we get x equals 1/2 y plus 9. Now we're going to subtract 9 from both sides. So we get x minus 9 equals 1/2 y. And in order to get rid of that 1/2, I'm not going to divide both sides by 1/2 because dividing by a fraction is not fun. But what I can do is multiply both sides by 2. So then we have g inverse of x equals, and we do want to distribute that 2 into the parentheses, which gives us 2x minus 18.